For lesson 6 homework, we're going to start to talk about some of our operations with square roots. So the first question is, which statement is not always true? The sum of two rational numbers is rational. Well, that's r plus r equals r. And we talked about in the past 2 days that anytime you got two r's, your answer is automatically r. The product of two irrational numbers is rational. Well, we didn't talk too much about two i's, but let's hold off for a second. The sum of a rational and an irrational is irrational. Well, anytime you got one of each, the answer is always I. And the product of a non-zero rational and an irrational is irrational. And that's the same rule right there. So we know those three are true, which means the only one that's not always true is number 2. Sometimes the product of two irrationals is irrational, but sometimes it's not. Simplify the following expressions. So if we do the square root of 4, which is 2, and the square root of 10 can't be rearranged, we get 2 square root 10. You could also multiply the two numbers that are out there, and you get the square root of 40. And for now, either of those two answers would be good. Same thing in the middle. We have square root of 9 is really 3, so it would be 3 times the square root of 3. Or if you multiply them together, you'd get the square root of 27. If we go over here, we end up with 3 times 8, which is 24, and 2 times 18, which is 36. Well, 36 is a perfect square. The answer is 6. So now we have 24 times 6, which is 144. So you can see how we have some combinations of rationals and irrationals here that work in a couple of different ways. For the adding and subtracting part, 5 square root 5 plus 4 square root 5, you're going to add the numbers out in front to get 9 square root 5. We'll distribute the square root of 7 to give us the square root of 14 minus the square root of 42. And we don't have the ability to do anything with that just yet, so we'll hold off on those for a minute. We have the square root of 5 times the square root of 4 minus the square root of 20. Well, order of operation tells us to do multiplication first. So 5 times 4 is 20, so we have the square root of 20 minus the square root of 20. Well, if you subtract anything from itself, you get 0. And then the last one is the product of negative 4 square root 3 and 7 square root 12 rational or irrational? Well, if we follow our rule and we multiply our outside, so negative 4 times 7 is negative 28, and then 3 times 12 is a square root of 36. Well, just like before, we end up with the square root of 36 giving us 6. And when we multiply those two together, we end up with negative 168. So as we do this, we end up with an irrational times an irrational giving us a rational, which we know is not always true. Sometimes it is, sometimes it isn't. But when we want to explain this, we can say when multiplied or simplified, you get negative 28 times the square root of 36, which is a rational times a rational, which is always equal to a rational. So when you multiply them out and then you talk about what your product is, which in this case, again, is a rational times a rational, your answer always has to be a rational number. So in this case, our final answer here is that it's going to be a rational answer for that product.